We're talking about the intermediate value theorem, and now we will look at a couple of examples. In this problem we're told, use the intermediate value theorem to prove that the cube root of 50 exists and is greater than 3 and is less than 4. Okay, instead of this cube root, I'm going to think about the function x cubed. Watch this. F of x is x cubed. And you know what that looks like. It zooms up pretty fast, something like that. And we're trying to find the cube root of 50, and we know it's going to be between 3 and 4, or we're going to show that it's between 3 and 4. So on the graph, if I find an x value of 3 and an x value of 4, these would correspond to f of 3 and f of 4. And I can compute those. If f of x is x cubed, then f of 3 is 3 cubed, which is 27. And f of 4 is 4 cubed, which is 64. So that's these numbers over here, my y values. 27 and 64. Now I'm going from y to x. Instead of just putting in an x value and calculating y, here I want to put in a y value of 50 and hopefully find some number x between 3 and 4. And so instead of putting in x and getting out y, if we're thinking of putting in y and getting out x, that's why this function right here ended up being the inverse of this cube root function. So f of 3 is 27, f of 4 is 64. This function is continuous. We know that. And that's worth stating because the intermediate value theorem only applies to continuous functions. F is continuous, and I'll say and 50 is between 27 and 64, and we see that visually right here. 50 is between 27 and 64, so there must be some x value down here between 3 and 4 such that f of that x value is 50. So 50 is between 27 and 64, and I'll go ahead and write it out. So there must be, and that's what we were trying to prove. We're trying to prove that it exists. There must be some number c between 3 and 4. Such that f of c equals 50. You might want to write out, according to the intermediate value theorem, there must be some number c between 3 and 4 such that f of c is equal to 50. And here's another example. F of x is x cubed minus 5x squared plus 5x plus 5. And we're told, show that there must be an x value between 1 and 3 where f of x is equal to 4. So this is pretty easy. The function is given right here, and we're going to find an x value between 1 and 3. So let's compute f of 1 and f of 3 and get some values. Well, f of 1 will be 1 cubed minus 5 times 1 squared plus 5 times 1 plus 5. So that's 1 minus 5 plus 5 plus 5. Those just cancel out. We get 1 plus 5 is 6. And f of 3 is 3 cubed. I'll work this out as I go. 3 cubed is 8. Minus 5 times 3 squared, that's 5 times 9, that's 45. Plus 5x, that's 5 times 3 is 15. Plus 5. And whoops, there's a mistake there. 3, this is f of 3. 3 cubed is not 8. That's not right. 3 cubed is 27. Let me fix that. Okay, that's correct now, and that works out to 2. So f of 3 is 2. So f of 1 is equal to 6, and f of 3 is equal to 2. We're trying to find a place where f of x, the value of the function, isn't 6, and it isn't 2, but it's 4, which is going to be in between 2 and 6. So I'm going to write, f is a polynomial, and therefore continuous, because polynomial functions are always continuous. F is a polynomial, so it is continuous, and again, that's worth stating because the intermediate value theorem applies to continuous functions. And then I'll say that 4 is between 2 and 6, and I'll just put dot dot dot. I won't write it out the whole time, but you should understand the reasoning at this point. 4 is between 2 and 6. Or another way of saying that is 4 is between f of 1 and f of 3, so there must be a value between 1 and 3 where f of x is equal to 4. That follows from the intermediate value theorem.